Hey there YouTube. I thought I would shoot a quick video talking about how to touch off turning tools with Mach3. So very quickly, it's sort of a multi-step process. The first thing you got to do obviously is physically load your tool into the holder. The second thing you have to do is find the center height of your tool. So the way I'm going to do that is to take a couple little test cuts here and just make sure the tool's on center. Then, after that, what I like to do is, my cat is just, yeah, okay, that's okay, buddy, it's good. After I do that, after I find center, then the process I like to use, I like to touch off in Z on a common point of reference. So I use the face of the chuck here to touch off the tools, all the tools in Z on the face of that chuck. That way, no matter what I'm running, no matter what's loaded into the chuck, how far it's protruding, I can always touch off on a common point. Then all my tool touch offs are good for, you know, every job that I'm going to run. It doesn't matter what I put into the chuck. Those tool offsets, they all work. X offset, very similar. All the X offsets they are a distance from, basically the values you load into your X offset registers is the position that the axis has to travel to put the tip of the tool on the center line of the machine. So all your X offset registers are just that. It's the distance that the X axis has to position to in order to put the cutting tip on the center line of the machine. Once you've done all that, your work offsets are really easy, or your fixture offsets are easy. You'll just bring up any tool, activate the offset, and touch off the 0 point of your work and just tell it that that's 0. It becomes really super easy. Another way you can do it, literally, if you know all your tools, the Z0 is the face of this chuck, you can use the scale. If you, like, for instance, you want to say, hey, I want my 0 point to be, you know, 3 inches from the face of that chuck, then you literally can just load 3 inches to the fixture offset. So, long story short, there's a lot of benefits, I think, to touching off a common reference point. So I'm going to go ahead and find the center height of this tool. I'm just going to take a couple quick test cuts, just like you would do on a manual lathe. Okay, so just jog this up there. Just going to fire off an M code here to so I can see what my spindle RPM are, or is. So I'm just going to give it an M3 just to tell it the spindle's on. So now I can see the spindle RPM, that's good. Going to jump into the jog wheel here, and I am going to slow down the feed rate to about 30%. So now I get a nice, everything's going to move nice and slow. So I'm just going to I think my tool's a little bit above center, so I'm just going to adjust that and take another cut. Okay, so I think I have this tool fairly well placed on center, so I'm just going to take a little cut with it. Yep, that's pretty good. That tool's on center, and yeah, that'll work. Alright, now that the tool is on center, can start the touch off process. So I'm just going to, for good measure, I'm going to rehome my machine in X and Z, and make sure we're where we need to be to reference out all the axes. Alright, great. So we are at machine position 0, 0. So what I like to do is use G59 as a fixture offset for touching off, and G59 has no values loaded into it. So when I activate G59, it's basically going to be the machine coordinate system. So what you have to do is first you need to let Mach know that G59 is active, and then you need to tell it which tool you're touching off. So I'm going to touch off T0202. So G59 is active and offset 2 is active, and when I go to program coordinate system, it still says 0, 0 because G59 has no values loaded into it and the tool offset has no values loaded into it. So that's right where you need to be. So now we're going to quit mode, and we're going to go to the tool table, and we'll get started. One quick point that I forgot to mention: before you touch off any tools, you gotta make sure that you tell Mach which tool offset you're loading values into, and that's what you do right here. Okay, so now I'm going to touch the tool off the face of the chuck, so I very carefully jogged it up here into position. I'm going to put it up here into the little jog mode, and I'm going to put it into step, and I'm going to set the step to 10 thou. And whenever I do that, I always like to take a step in the opposite direction just to make sure I'm not going to crash. So it's good. So now I'm going to very carefully bring this thing in a little closer to the face of the chuck, and hopefully not do any damage in the process. Okay. And now that I'm there, I'm going to go down to a smaller increment, 1 thou. Once again, I like to go opposite direction once just to make sure we're where we need to be. Get it close, and basically what I'm going to do is I'm going to touch off with this 5 thou shim, and until I I know that I'm 5 thou away from that surface. So I'm just going to go put the phone down and do that right now. Okay, so I have very carefully, as you can see this, I've very carefully jogged the machine until that 5 thou shim is just barely being held into place by the tool. So I can drag it, so there's still a little gap there. So I'm pretty close to being exactly 5 thou away from the reference point. So what I'm going to do is come up here to my part zeroing coordinate. I'm going to put, what I want to do is load a value in here, 0.00. I've noticed for some reason Mach is glitchy. So if you get to a point where it won't, if you have this situation where it won't let you load values there, what I've done is I've had to, again, the cat is still crying. What I have to do is quit mode, maybe go to manual, maybe quit mode, go to auto, quit mode, go back to tool table, and 9 times out of 10 that cures the glitch. Now I can put 005 in there and press enter, and now when I hit touch Z, what that should do is load a value into the Z offset register. So there you go. It just loaded a value into the Z offset, and now the machine now thinks that it's at a position of 5 thou, which is exactly what you want. The G59 coordinate system is active, which is had no values, and I just touched off that tool on a 5 thou shim. Told it that right here, and after it set the register, it loaded a value, and it now thinks it's at 5 thou. So that's perfect. So that worked just the way that I wanted it to. So now we have a, if we go to our tool table, and we have a value loaded in there for tool number 2 in the Z position. So that's exactly what we want. So the x-axis is, or the z-axis is touched off. So now we have to get the x-axis taken care of. So the way that I'm going to do that is you basically need to touch off a known diameter. So if I could, one way to do it, if the diameter of your chuck, if that's a known diameter, you literally could come up and just touch off the diameter of the chuck, and that would get you pretty close. I don't have my tool post set back far enough. I have 2 positions here for my tool post. I don't have it set back far enough to get to the outside diameter of the chuck. So I'm going to take a test cut. I'm just going to very gently take a light cut on this little chunk of aluminum, and then I'm going to measure it, and then I will know exactly where the tip of that tool is. So I'm going to go ahead and do that right now. Take that test cut. So what I'm going to do is I'm going to press tab, bring up the, I guess the jog window, whatever you want to call that. And my x-axis is pretty slow on this machine, but my z-axis is fairly fast, or I guess at least it's faster than the x-axis. So I'm going to slow down the feed rate quite a bit. I'm going to slow it down to like 4.8. That's nice and slow. So that's going to let me take a test cut. So I'm going to fire up the spindle and come in here and take a test cut. I don't think I'm getting 100% clean up, so let me take one more pass here and try to get under the outer round. Okay, so it looks like I got clean up, and now I'm just going to leave the x-axis exactly where it's at. Not moving the x-axis. I'm going to move the z-axis though, get the thing far enough out of the way so I can throw a mic on there and take a measurement. So let me grab my little micrometer and go ahead and do that. Okay, just taking a quick measurement. And it looks like I'm at 475, 85, 95, 96, 497. So, see if I can, there we go, one-handed, not good. So my test cut is at 497. So what I'm going to do is come here, and hopefully Mach isn't going to glitch out on me. And I'm going to tell it that I'm at 0.497. Press enter, and I'm going to get rid of this jog screen, and what I'm going to do is tell it to touch X. So when I hit this button, the touch X button, the number should change on the screen, and there we go. So the value just got loaded into the offset that makes this tooltip here match up with this 497 diameter. So if I go to the tool table editor, you can see I have a number here, 1.00145, and what that is the position, the machine position of the x-axis that puts the tip of the tool at x0. Okay, just to confirm the position of the x-axis, I'm going to MDI a move here. I'm actually going to tell it to go to rapid to x0. So you enter that command. So right now it's hard to see, but the tip of that insert is right in line with the center line of the machine. I can visually verify that. And the program coordinate system says x0, and when I switch that to a machine coordinate system, the machine position is at negative 1.0015, which is exactly what matches the x-axis offset register. So the offsets, they hold the values, they hold the machine position that puts the tip of the tool on the center line of the machine for the x-axis. Okay, so now we double check the x-axis. Now I'm going to just do a quick verification on the z-axis. So I am going to home out my machine. I'm going to say set z home and set x home. We already verified x, doesn't really have anything to do with z, but so right now, if I hit machine coordinates, everything's at 0, exactly where we want it to be. If I hit program coordinates, so right now G59 is active and tool offset number 2 is active. And what that's telling me is right now the tip of the tool is at positive almost exactly 2 inches, 2.0029, and it's at positive z of 6.6498. So we want to double check the z. So that number in the z, 6.6498, matches exactly what's in the z-axis value for tool number 2, negative 6.6498. So once again, the value for z is the distance away from home position to get to the reference point, which is the face of the chuck right here. So it's the tool offset value shifts 0 from the home position to here, negative 6.6498 inches. So logically then, when I am at the home position, the machine home position 0, 0, and I activate the tool offset, the machine now thinks that it's exactly 6.6498 inches away from the point that I touched off on. And this is a 6-inch scale, so you get an idea. That's pretty much exactly where it is. So now you can touch off every tool that way, and no matter where your workpiece is, you'll always have a common reference point for all your tool touch-offs. So the next step will be to set your fixture offset. That's really easy. Okay, so all your tools are touched off, and it's time to set a fixture offset. So what you want to do is, first thing you want to do is MDI whichever fixture offset you want to touch off. So you pretty much always want that to be G54 for all your lathe programs. So I'm going to activate G54. When I do, these numbers are going to change. So they just did, only in the Z. And now we're going to load a value into G54's Z-axis. So let's just very quickly see what's there now. So right now, the 0 point for G54 is 1.9615. So it's exactly, currently it's set to almost 2 inches away from face of the chuck. I am going to just pick a point in air and touch it off. Now, what's worth mentioning is there's no values in X for the fixture offsets. There really is no need to load any value in X for the fixture offsets ever. X is all controlled by the tool offsets. If you need to adjust the diameter that a tool's cutting at, you're going to change the tool offsets. Really, there's no need to really ever load a value in the X register for work offsets on a lathe. Okay, so now I'm going to set the Z value for my work offset. So I'm on my manual screen. G54 is active, and just do that just to double check. G54 is active, and what I'm going to do is jog the tip of the tool. Oh, and I'm also, just to be sure, tool 02 offset 2 active. And now I'm going to just jog the tool to some point. Let's just say right about there. So I am, let's try to make it go out to 3, just to get close. So I am approximately pretty close to 3 inches, just a little bit less than 3 inches. So when I zero the tool out there, it's going to load a value into the fixture offset number G54, and the Z value, it's approximately 3 inches. So on the manual screen, I'm just going to click on the Z value. I'm going to say you are now at 0, and enter. So now the machine thinks where the tip of the tool is right now is 0. And when I go to my fixture offset page for G54, you can see that it loaded a value. It actually, the tip of that point is exactly 2.9692 inches away from the face of the chuck. So that's my 0 point. So that's it. When I run my program, it's going to work to that point. It's going to use that as my Z0. And touching off the face of the chuck makes it really easy. So, like I said, if you want to eyeball it, you can just measure it. So let's just say, so my part's a little bit less than 2 inches. So let's just say I want to set Z0, 2 inches. So I'm just going to go into config, fixture, and I'm just going to say, hey, I want Z0 to be 2 inches, right on the money. Press enter, and save, and close. Now, if I MDI, let me just reactivate that offset. I'm going to say G54. Now it just changed. So now it thinks the tip of the tool is at 0.7898 away from the Z0 point. So if I MDI G0, Z0, put the tip of the tool, 0, almost exactly, well, it should be precisely exactly 2 inches. So there you go. That's how you touch off tools and then set your fixture offsets. Okay, so I just thought maybe I better do one more thing just to make things really clear. So I'm actually going to really physically touch off this little slug here, this little blank from my little program that I'm running. So literally what I'm going to do, just like we touched off the chuck, I'm going to bring the tool over, and I'm going to get as close as I can without crashing the tool into the work. And what I'm going to do is I am going to jog the tool with the spindle on until it just scratches the face of the part, and then I'm actually going to tell it that I am not at 0. I'm going to tell it that I'm actually 5 thou in front of 0, positive. That way it's going to leave 5 thou to face off. So I'm just going to go ahead and do that right now so you can see how I... Okay, so the spindle's on. Just going to jump into a mode here and slow my jog down to a nice safe rate. And here we go. All right. Probably hit that a little harder than I want it to, but working one-handed here. So what I'm going to do now is I'm just going to come up here. I'm going to tell it, you are now at 0.005. We'll say 3 because I cut a little bit. 0.003, enter. Now the machine thinks that that position is positive 0.003. So when I go to 0, I'm definitely going to face a little bit off. So, all right, there you go. Now I am ready to machine my part.